Hi, welcome to Tutorialspoint. In this video series, we are going to begin the Oracle SQL. As we may know, like Oracle is an organization which deals with the number of softwares nowadays, and basically the most important part of that Oracle is the database. So in this video tutorial, we'll see how can we install the Oracle SQL database and how can we start working on that. So before getting started with the Oracle, let's find out what this database is all about and why do we need it. You may have come across a number of websites which ask you details like email ID, mobile number, and the sites like Facebook and maybe some other profile or community sites ask so many details from you. Later, when you log in, you can use the same username and password which you have used while filling up the form, and you will find all of your details like your pictures, the videos you shared, or anything. So basically all these things are stored somewhere in the backend in which the user cannot make a direct interaction, because user generally makes the interaction with the user interfaces, that is the UI, maybe the web page, maybe the mobile application you are dealing with. But all the data is actually stored somewhere in the backend called the database. So this database actually provides the permanent storage of the data. So when we talk about storing the data is actually stored in a tabular way, and all the data is related to each other. For example, if I'm talking about the database of a company like Tutorialspoint, so here the tutorials and the writers who write those tutorials, the video tutorials, all are somewhere related to each other and will be stored. The data will be stored in the tabular way. But in the database, table is not the only thing which is stored, as it may have the number of different types of objects for the different purposes. So like here I just talked about the tables. We may get something like views, indexes, synonyms, procedures, functions, which you will find in this video tutorial. Different objects have the different roles to perform. Like table goal is to store the data. Similarly, if I'll talk about the views, it will be used to restrict the data. Maybe if I'll talk about the triggers, it will do some validation, or maybe will take some implicit actions. So basically each and every database objects have a different role to perform. So basically in database, it refers to the related set of data and the way it is organized. So once we have the database, obviously we should have something which will help us out to interact with the database. And in that sense, we will talk about the DBMS, that is Database Management System. So Database Management System is basically a way to interact with the databases. As here, DBMS is a computer software application that interacts with the user or other applications to capture and analyze data. For example, there is a database, I want to access the database directly. Maybe if I am a DBA, I can sit on the database server, can start fetching the data directly. But generally what we do, this database would be accessed by some application. Like I just give an example of Facebook. The data is stored in the database, but that Facebook application is actually retrieving the information from the database. So this is all possible because of this DBMS. So this DBMS is designed to allow the definition, creation, querying, update, and administration of database. Definition means if you want to create a new table or any database object, that is the creation, definition, and similarly you can create the database objects. Once you have defined some objects like table or maybe some, and you have stored the data, you can query that. You can update the structure or the data, and you can administer, like you can pass some validations, you can set some privileges to the different set of users and all. So these are all can be possible because of this DBMS. Data sharing, data security, data integration, data access are some major advantages of DBMS, that is data sharing. If you want to share your data, putting the security in data integration and accessing the data. So all those things can be done with the help of the DBMS. But nowadays the DBMS which we are working is RDBMS, that is Relational Database Management System. Basically this model is launched by Dr. E.F. Codd. So basically he wrote 12 rules and if any database will follow those rules would be a RDBMS. Alright, so this is a relational model, means each and every object in the database will be related to each other. RM purpose is to provide a declarative method for specifying the data and query. And whenever you will work with the most of the RDBMS databases available, you will have to use the SQL as the query language. SQL, which stands for Structured Query Language, is basically a standard language using which you can access almost all the RDBMS nowadays. Yes, of course there will be a bit difference in each and every SQL, like maybe the function name will be different, something in Oracle will be having a different name in maybe MySQL Server. So some basic changes will be there, but overall the language outline is going to be same, and we are going to work with the SQL. So let's have a quick look what this SQL is all about. So as I just said, SQL stands for Structured Query Language. It is designed by Donald Chamberlain and Raymond Boyce in 1974. So initially it was used to retrieve the data from some of the databases, but since this language is very easy to learn, it is almost like an English language, so that's why it is categorized also in the 4th generation of language. 4th generation language, which is basically very much English type language, like we used to talk to each other. If I say something like delete from employees, so even if you are not familiar with the SQL, you are getting actually what I mean. If I am saying delete, what does that mean? So this is as simple. So its basic purpose is to it's a special purpose language designed for managing data in RDBMS. Using this SQL command, you can do different types of action, like you can create the new database object, you can insert the data, you can update the data, retrieve the data, you can delete the data, you can drop the structure of the table, you can do anything, right? Like allowing the user to get some privilege, revoking those privileges, each and everything can be done using this SQL, that is Structured Query Language. But as I just listed many of the tasks that we can do using SQL, we can actually categorize them as per their commands. So here we have the 5 major aspects of the SQL, 5 major classifications of the SQL, that is the DDL, that is Data Definition Language, Data Manipulation Language, Data Retrieval Language, Data Control Language, and Transaction Control Language. So let's have a basic idea of each. Data Definition Language means any SQL command which is actually used to define some database object, like if I'm going to create a table, a view, an index, or anything. I'm adding a new object, I'm adding something new in the database. So if any SQL command is affecting the structure or the information of database, I will categorize them in the data definition language. In our further videos, we will of course give a deeper look in each of these segments. Data manipulation language. Once you have created the table, now what? You will have to insert some data. When you insert or manipulate some data, it doesn't affect the structure of database, but yes, it does affect the structure of the table. Like if I'm entering a new record, one new record is added in the table. If I'm updating, some data is going to change. When I'm deleting, some rows are going to be removed. So this is the data manipulation language. When any SQL statement will affect the data inside a table, I will categorize it inside the DML. Now once we have the data, we can start retrieving that. So that part will be deal with the data retrieval language or data query language, maybe in some databases. Data control language. This data control language actually deals with the accessibility. Like if I'm working in a centralized database and there are number of users who can access the same database, I will have to specify the goal. For example, I should not say goal, basically I should say roles. So when we have the different set of users and all are working in a centralized database, each user would be having a different role, means that role will be defining like how much a user can access. Even I can access a Google database through Gmail, but I can only check my mail. So somewhere I am getting restriction. So that is what we can do right here. If there is some user who are in admin level, I will obviously allow them to create a table. They can access all the data from the table. But if there is some third party user type user is there, then I will only give some view of the data, means some particular things can be retrieved by some set of users. Transaction control language. Transaction control language simply means when I am executing a number of SQL statements altogether, then I should take care of that transaction. Maybe if I'm transferring some amount from my account to my friend's account, so there will be a couple of SQL statements will be required. For example, first of all, I will update my account balance, will deduct some amount, then the amount of my friend's account will be added. So there are a couple of update statements or any particular statement, any DML statement is gonna execute. But this transaction control language will ensure us like if it is getting successful, both the commands or all the commands participating in a transaction will execute successfully. Otherwise, if there is something wrong, obviously the whole transaction will be rolled back. Not the half or some percentage of the transaction will be successful. Either it will be fully successful or fully failed. So these are the different classifications of SQL. How can we start installing Oracle 11g Express Edition to our systems? For that, first of all, we will have to go to the official website of Oracle and we'll have to sign up. Once you are logged into the website, you can find and download the Oracle 11g Express in your system and then can start installing it. So let's find all such things practically. In order to install Oracle 11g Express Edition in your systems, first of all you will have to come to the Oracle official website, that is oracle.com, and here you will have to sign in. If you don't have any Oracle account, first of all you will have to create a free account out here and then just log in with that. As here you can see like welcome Anadi, that means I am already connected with this. After this you can simply come to the downloads and here you can see Oracle Database 11g Express Edition. Alright, if you don't get that, you can also make a search for that particular tool. So let's click on this Oracle 11g Express Edition. Let's accept the license agreement, and as soon as you will do that, here you can see like different options are available. If you are working with Windows 64-bit operating system, you can go for this. For 32-bit Windows operating system, you can go for this one. And if you are working with the Linux operating system, you can come here. Since I am here working with the Windows 64-bit operating system, so I'll click on this, and as soon as I'll click here, the downloading is begun. Once it is done, we will start the installation process. So once the setup is downloaded with a zipped file, here I have already extracted that zipped file, and inside this I am getting the folder called disk1. If I'll come inside, I'll get a setup.exe, so I'll simply run this, and here the installation wizard is getting loaded. Once the loading is done, you will be able to see this installation wizard. So just click on next. Here you will have to accept the terms and conditions. Say next. This is the location where your Oracle database will be installed, and it is the selected version. It is showing you the required space for the particular drive, which I have enough, so let's say next. Now it will ask you the password for the admin accounts such as sys and system. When you install the Oracle Express Edition, it automatically creates a database with the name XE, and there are two admin users for that database. One is sys and another one is system. So whatever password you will enter here, once you are done with the installation, you will be able to use that password in order to do the login. So here I will enter something, and once you are done, say next, and here you can click on install, which will begin the installation of Oracle 11G Express Edition in your systems. Depending on the basis of your configuration, it will take some time. This complete installation will be covering in a number of segments, like installing the database software, creating the services, running that services, and finally creating the database. And now we are done with the Oracle installation, and now we are good to use this Oracle database. So as we have successfully installed Oracle Express 11G to our systems, now let's see how can we start implementing the basic operations like getting connected with the Oracle environment, and how can we start working on it. So let's find it out now. Now to get started with the Oracle SQL implementation, first of all we will come to the run and type cmd so that it will open for command prompt for us. Here I will pass a command like SQL plus. So as soon as I'll say enter, it will ask the username and then password from us. So by the time we install the Oracle database, we noticed like it was asking the username and password for the couple of users, that is sys and system. So if I will try to log in with the user system, it will ask the password, and I'll have to enter the same password which I entered by the time I installed the product. So you see, if I'll do it correctly, I got connected with that. Now in order to do the disconnection, you would simply type the disk, it will disconnect you from the database. And now again, if you want to connect it with the sys user, so you can simply like con, that is connect sys as sys DBA. So you will again enter the password, so just type like whatever password you have entered, and again you see it is getting connected. If you will use the system username, you will not have to ask as sysdba, but if you will try to connect as sys, you will have to enter as sysdba. Now if you want to see the current user using which you have connected, you can simply like show user, and it will show you the name of the user. Now after that we will begin with the database DDL implementation. For that we should have the admin rights. So sys and system both are the admin users, and we will be good enough to start with the DDL statements by these users. Now as in the introduction we discussed about the various classifications of SQL, the data definition language was one of them. And here in this video we are getting an introduction of the DDL statements. So as we know, DDL stands for the data definition language, and these are the commands which are actually categorized inside this data definition language. So basically any SQL statement which affects the structure or the information, or I should say the metadata of the database, we will categorize them in the DDL, that is data definition language. So let's have the look what all statements are there. So first of all, create statement. Create statement means when you create any database object. So obviously whenever you create a new object inside a database, it will definitely change the structure of the database and as well as the metadata of the database. Obviously the database should know that okay, there is an object with such particular name. So the metadata and structure both will be modified. Then alter. When you alter the structure of any existing database object. For example, if I have created a table and later I want to add or remove any of its column, so I can easily do that with the help of alter table. Then drop. If you want to drop the structure, means after executing this drop statement for any particular database object, the definition of that object will no longer exist. Similarly, truncate. Truncate is the statement which will only execute with the table. Whenever you will execute this truncate statement, all the data of the table will be gone away. So maybe you think like it's just removing the data, how come it is categorized in the data definition language? So basically, when you execute truncate statement, it removes all the data from the table, but it will not remove the structure, and along with the removal of data, it will also release and free all the spaces occupied by that particular amount of data. So in the metadata or in the data dictionary of Oracle, the information like the percentage of memory used and percentage of memory which is free will be changed, because obviously if my table is consuming maybe 20 KB or 20 MB of data, that will be changed to some different values. So this truncate will actually change the metadata and it removes all the data along with releasing the spaces. So whatever you will execute will not be able to roll back and all the data will be deleted. Now next is rename. So rename is basically the DDL command which renames any particular object. Like if you want to rename a view, a table or anything, you can go for this rename command, and obviously when you rename something, the metadata will be changed again. All these DDL statements are auto committed, means the time you will execute them, it will be committed and you will not be able to roll it back. Means if by mistake you dropped a particular object, you will not be able to roll that back. The table or any object will be gone. So you must have the administrative privileges before starting working with these set of statements. So since we are working as an admin in our databases, we can easily execute any of such commands. So let's start working on the DDL statements. We are going to work with the tables. As in the introduction I told you, like database is the collection of various database objects and table is one of them. Basically table is the most important part of the database as it does the major role of the database, that is storing the data. So first of all, we'll start working with the tables, we'll start storing some data, and then later we can go for some more objects, but in the beginning for now we will work with tables only. So in the previous video we have just gave a look to the data definition language, and create is one of them. So in this video we'll work with the how to create a table. So if I talk about table, so you can classify a table into two parts, that is the data dictionary and user tables. Data dictionary is basically something which stores the metadata, means the core information of any Oracle database will be stored in the data dictionary. These are the system tables, you can say. And the tables on which we are gonna work is the user table. So basically any user which has the permission to create a table will be able to create the user table. We cannot do any changes in the data dictionary. So basically while creating a user table, or I should say tables only, you must give a valid table name. When I say valid table name, that means there should not be space in the table name. The name must begin with the alphabet. No special character or no number should be there in the beginning of a table. Similarly, if there is any keyword in the Oracle database, you should not use that keyword as a name of a table. User must have a create table permission and storage area. When you create a user, apart from the admin, it doesn't have any privilege. So any admin should give the privilege of create table along with the storage area, that is the table space. So where a user can create a table. If there are n number of users in a database, each and every user would be having its own schema. So doesn't matter whichever user is creating a table, basically it will be created in that user schema only. For example, I am Anadi, and if I am creating a table in my schema, so that will be accessed by some other user with Anadi dot table name, the schema name dot table name. But being Anadi, I can directly access my table because it is only in my schema. When you create a table, you name a number of columns inside that along with the data types. For example, if I am creating the employee table, there will be employee ID with a particular data type, means the type of data I want to store. Similarly, first name, data type again. So you will have to pass the number of columns which you want to create in a table, but the default value would be passed by using the default keyword if you want to store some default value. For example, if there is a column called date of joining in my table and I want that a default value of today's date should be there even if user is not entering anything, so I can specify that as well using the default keyword. So now let's go to the system and see how can we start working with the creation of a table. Now for starting the create table statement, first of all I'll have to connect as an admin user or any user who has the create table privilege along with the table space allocation. So currently my user is sys, because so far we have not covered how to create a user, so we will continue with this particular user itself. Now here I am good enough to start with the create table command. So let's start with a very basic one, like I'll say create table, and after that you can put a table name like such as employees. Alright, and after that you can just pass the list of all the columns which you want to create with this create table employees. Now opening the parenthesis and closing it, in between this you can pass the number of columns. So let's separate them a bit. Alright, so I'm just separating the whole command in a separate lines just to enhance the readability. So first of all I will have to pass a column name. So the column name is, let's say, emp id. Alright, and here I'll pass the data type such as number. So it is the employee ID which will only take a numeric value by the time we will start entering the data. Now separating it with a comma, you can pass another column name, let's say first name, and here I will say varchar2, and after varchar2, which is the character data type, variant character data type, means if you are allocating it for 20 characters and I enter something lesser than that, let's say Anadi, so out of that 15 spaces will be released, means the 15 character space will be released, it will not block that. So let's say it's the first name. Similarly, let's put one more column, let's say last name, varchar2 20, email ID, varchar2 again, let's put 50 or anything. Alright, after this you can pass something like gender. I want to get only a single value in the gender, either M or F. So for this, when the input character strings are fixed, I can go for char as well, because char is a fixed size character space. If you will allocate 10 spaces for something and you enter 5 characters only, even though it will consume the complete 10 character space, because in the remaining space it will simply store the spaces. So in the fields like contact number or mobile number also, I will prefer the char when I am sure like the character strings or the length of a string is same or consistent. Now let's add another column here with the name date of joining, and here I'll pass the data type as date. So whenever you will enter something, it must be of the date format. Now after that you can also go for the default value. Every column has a default value which is null by default. If you want to change that default value, you can come here with the keyword called default, and here you can specify any default value with an expression. make sure you are not using another column name in this default expression. So here I'll say like sysdate. Sysdate here is a function which returns the current date of the system. Similarly, let's go for something like mobile number is already done. Alright, so let's take one more column here. Just say that is department ID, and here again I will enter the ID of that department, which would be in the integer format. So once you are done with all the columns, just close the parenthesis which you have opened in the beginning and terminate the statement with the semicolon. So as soon as you will press enter, you see table is created. Now once you have created this table, and if later you want to see the structure of that particular table, you can go for the describe command. Describe, or in short you can write DESC, and after that you can simply say employees, means whatever table name you're talking about, and it will show you the structure of that particular table. This describe command is also applicable for the data dictionary. So whenever you want to query any data dictionary, you can come here and can check the structure of that data dictionary. So this is how you can start creating the tables in using the admin accounts like sys or system in your Oracle database. Now, as we have already created a table, if you want to modify the structure of that particular table, you can do that with the alter table command. So basically here alter table can add a new column in your table, or if you want you can modify any existing column, you can drop any existing column, or you can rename any existing column. So these are all the things which can be performed by the alter table. Later when we will cover the constraints, you will also be able to add or modify the constraints by the alter table command. If you talk about dropping of a column, the column will no longer be a part of the table. But if you want the structure of the table should not change, but I don't want that particular column to be there in the table, you can also use the set unused option to disable the column of the table. So let's perform all these tasks practically in the system. So once we have created a table, as in the previous video we have created the employee table having this structure. So after that, if I want to make any changes in the structure of this table, I'll have to go for the alter table command, because dropping the table will not be a good idea, because your table would be carrying some data as well. So let's see how can we go for the alter table. So for that we'll simply write first of all alter table and then the existing table name. So here the table name is employees, and after that you'll have to choose what action you need to take. For example, here I want to add a new column in this particular table. So for adding that I'll use the add keyword, and after that the column name. For example, I want to add the date of birth column right here of date type. If you want to pass some default value as well to the particular data type, to the particular column, you can go for the default keyword and after the value which must be of the same data type. So here I'm not taking any default value for the date of birth at least. So let's say enter after semicolon, and you can see the table altered. If I'll write the describe command again, you can see the date of birth column is added at the last. You cannot change the order by the time you are adding a new column. The new column will always be added at the last, but it really doesn't matter, because by the time you will be retrieving the value, you can choose the order on which you want to get the columns of the data. Now if using the add keyword you want to add multiple columns at a time, you can do that as well. In that case you just need to pass the parenthesis, and after that the name of the column along with the data type and the default value if required. So let's say here I want to add another column called salary, and here is the data type, let's say number, and here I'll pass the length of the column 10, 2. That means 2 number out of 10 will be decimal, and before that you can enter up to 8-digit number. So 10 is the overall size of the number, and out of which 2 decimal places will be there. So let's say comma after that, this is the first column, salary. After that, let's say any XYZ column, col1 of number type I want to add. So you can just form a list like that, and as soon as you will say enter, the table will be altered, and in the structure the changes will be there. So as you can see, the DOB and salary and col1, these three columns has been added to my employees table. Now, if I want to change the data type of any particular field or the length of any particular field, I can do that also by using the alter table command. So for that, alter table employees, again there must be a existing table name which you want to alter, and after that whatever you want to do, like modify. Initially I went for the add, now it's about modifying. So what you want to modify, for example, if I want to change the data type of field col1 from number to varchar, so I'll do that, alright, along with passing some size. So basically when you are doing that or any changes in the existing column, you have to make sure like the changes is compatible with the data as well. For example, if any of your column is having varchar data type and the column is accepting some character values like anadi, Tutorialspoint, whatever, later you will not be able to convert that as a numeric value, right? You cannot alter the data type to number because such string values cannot be converted to the numbers. Similarly, if suppose I want to decrease the size of this email ID field from 50 to 40, I have to make sure like any particular data which is there in the table is not exceeding 40 characters. Only then the table will be compatible and the changes will be there. So here I can easily convert the number to varchar, though I don't have any data, but let's see. So here you can see table altered, and again if I'll run the describe employees command, I can see right it is something varchar 2 and 10. Alright, so this is how you can modify any existing field. Now after that I can go for drop column command. For example, if I want that DOB is something a very personal detail, I want to keep the personal details of employees in a separate table, the professional details in some separate table. So in that particular scenario, let's say I want to remove the salary column from this table and I'll create a separate table for that. So what can I do? I can simply drop this column. So for doing that, I'll say alter table employees, and after that I'll use a drop keyword, and after that you will have to mention the column, drop column, and then the column name. For example, I want to drop salary column, so it will be dropped. As you can see, table altered, and again if I'll go for the describe employees command, you will not be able to find salary column in the list. Basically, whenever you drop a particular column, all the data of that particular field is dropped and the memory is released. But for example, if there is a lot of bulk in your database because of there are a number of users are requesting from your database server, so in that particular time, dropping a column will consume more resources because first of all, it will remove the data of that particular column, the structure of the table will be deleted, will be modified, and after that the resources will be released, means the memory will be released. So overall it will take much time and it will be a time consuming process which may cause the degrade in the performance of the server. So in that particular time, what you can do, you can simply use the set unused option for a column. For doing that, what I'll write is alter table employees set unused column col1. So as soon as you will execute, you can see it is being altered, and if I'll go for the describe employees command, you will not be finding the col1 column right here because now it is logically not a part of this particular column, but the only difference is the memory is not released. And by the time there is less traffic and less requests from for your database server, you can drop this unused column, or all the unused column which are there in your table by writing alter table employees, or whatever the table name is, employees drop unused columns. Alright, so you see now it is altered. You cannot recover, or you cannot get the unused column back to the table's definition. You will have to re-add that particular column. So this is how you can drop any column, you can modify a column, and you can add a new column using the alter table command. Now we have already created and altered the structure of a table. If I want to drop a particular table, obviously permanently, because it is a DDL statement and it will not be rolled back, so I can do that as well with the drop table option. It is very simple and straightforward, so let's check it out practically now. Now if you want to drop the table, of course all the data will be removed from the table, but the structure will also be dropped. Means once you have dropped a particular table, you cannot query or you cannot do any particular operation with that table. You only have to create a new table again from the scratch. So for dropping, it's a very straightforward syntax, like drop table and then employees, means the table name. So when you will execute that, you can see table dropped, and now if you will see, say describe employees, that's the table name, it will simply say like object employee does not exist. So this is about the drop statement of DDL. In the previous videos, we went across the drop table command. When I will use a drop table, it will remove all the structure of the table. Means the data along with the structure of a table will be removed from the database structure. But if I want the table skeleton, means the structure should be there, but I want to remove all the data, I can go for the truncate table statement. This truncate is actually categorized in the DDL because when you execute a truncate statement, it releases all the memory also along with the removal of the data. So it will not be able to roll back because there is no memory reserved for that particular data and everything is released. So basically releasing that memory will do the trick, which will actually affect the metadata in the data dictionary of the particular database. So that is why the truncate table is a part of DDL. But it is a very simple and straightforward command. So let's see practically how can we truncate any existing table with the data. So in truncate, basically you will have to simply write truncate, then table and the name of the table. Since we have not started with the DML so far in the SQL, so I can't show you the actual difference between the things, but when you will execute this truncate command, when there is a data, you can simply see like all the data has been deleted and you can't do the undo in that particular scene, because when you execute the truncate statement, the memory will also be released and your table will not be able to get that particular table data back. So this is about the truncate. Once you start working with the DML, you can try this command to check like all the data will be removed from the table, but the structure and the table existence will still be there in the database. And since if I'll say describe employees, you can see like the table is still there, but the data will not be there for sure. We will start constraints. Once we are done with the table creation, a user can enter any record into it. But we want to make sure like whatever values user are entering should be validated. For example, if I have placed a column called salary in the table statement under the table structure, the value of that salary column should not be in negative, as we have specified that it will only take the numbers of a certain digit, but you can anytime place a negative value in that and it will also accept that. But obviously a salary in minus is not the correct data. Similarly, when I have created the email ID or maybe mobile number, they must be unique. So I need to ensure, like, if any particular email ID is entered or any mobile number is being entered, another user should not repeat with the same value. So putting all those things in mind, we can actually apply the constraint with the table. So basically, constraints will be used as a validator which will validate the incoming value. If the incoming value is proper, only then it will be allowed to enter in the table, otherwise it will be declined with the error message. If you want to create the constraint, you can either specify the name of the constraint or not. Basically, if you specify the name, in later when you want to disable it or enable it, it will be easier because you have given your own name. But if you will not assign any name, Oracle Server will implicitly assign any name to that constraint. Once the constraint is added, you can enable or disable that, or you can also drop that constraint. For example, if you want that at a particular time only, I don't want to work with my constraint with a particular constraint, so I can disable that. Later I can enable that again. I don't have to give the complete definition. I will just pass the enable keyword with the constraint name and it will be enabled. But if you permanently want to drop a particular constraint, you can do that as well using the drop keyword, which you will see how to do that practically. Now, while adding, either you can add a particular constraint at column level or at table level. Basically, when we create a table, we have already seen how we can create, like we will specify each and every column name separately. While defining a column only, if you want to pass the constraint description, it will be a column level constraint. But after creating all the columns, if at the last you want to specify all the list of constraint, that will be the table level. The major difference between the column level and table level constraints is, like at column level, a single constraint can be applied to a single column only, but at table level you can share a single constraint with multiple columns. So let's see what all constraints are basically available which we can add. So here you can see, like null, unique, primary key, check, foreign key. These are the major constraints. Let's check them individually. Like not null constraint is something which will ensure on a particular column it will never accept a null value. For example, if I have an employees table, they must have a name. So on the column called first name, I can simply pass this not null constraint so that every time you are entering a new record, you must pass a name. Unique constraint is something which will ensure the uniqueness of the records. As in the example I said, I want the mobile number or email ID columns should have a unique value. So in that particular situation, I can pass the unique constraint. But if there is a column who is representing your column in your table in a very best way, you can actually make it as a primary key. By the time you make a primary key, it will be having a feature of not null and unique. Means any field which is decorated as a primary key must have a value and that must be unique. So not null and unique both will work with the primary key. But as I said, we should have only one primary key in a table. For example, if I'm talking about employees table, employee ID is something which every employee must have, and along with that it will also be unique. So, and employee ID is representing any employee uniquely. Alright, means mobile number is not an actual representation of an employee, email ID is not a representation of an employee, but an employee ID is. So such fields can be marked as the primary key. Check constraint will be used when you want like any particular coming value must be of a particular type. For example, if I'm having a column called salary and I don't want any value less than 5000 should be entered into that, so I can pass as a check constraint. Similarly, if I have a column called gender which is accepting a single character, that is M or F makes sense, but if you enter anything like A, B, C, D, that doesn't make any sense. So those things can be validated by the check constraint, which will ensure like a particular any value which having a particular condition satisfying will only be allowed to enter in the table. Now next is foreign key, which is actually a part of referential integrity. Suppose I have a couple of tables, that is the employees and departments. So any employee will be working in a department, but the major list of the department must be residing in a departments table, in a separate table. So I want to make sure like any employee is working in a department which is there in our organization. So to ensure that, we should pass the referential integrity using the foreign key. In our coming videos, we will start applying each and every of these constraints individually. We will cover not null constraint. Not null constraint is used when I want that there must be a value in my particular column. For example, if I have a table called employee and I have a field like first name, last name, email ID, so I want some of the details should be mandatory. As in the UI also, you may get some asterisk like symbol which makes sure like you must enter some value before submitting the page. So in the backend, to make it sure that any particular field is having a value, you can pass the not null constraint on a particular column. Basically, not null constraint can only be applied on the column level, you can't pass it on the table level. As I said earlier, while adding the constraint, you may or may not pass the constraint name. So let's see practically how we can add a not null constraint on a table at the time of creation as well as on the time of altering the structure of a table. So to apply a not null constraint on a column of a table by the time you are creating a table, so in that the create table statement will remain same as we have done earlier. So I will simply write a create table statement, and here I'll just create a sample table, let's say sample1, and after that I'll just pass the number of columns. So if you want to create a column, what you will do, you will just say column name like col1, just pass the data type, let's say number, and after that the constraint description. Since here not null constraint can only be passed at the column level, so that is what I am doing here in column level, because here I am defining a column and right after that I can pass this not null constraint. So for that, what I'll do is I'll say constraint and then constraint name like sample1 underscore col1 underscore nn, any logical name. Alright, if you will not give a name, Oracle Server will automatically assign a name, but it will be better if you will pass a name by yourself, because if later you want to disable or drop this constraint, you can do that easily. So here what we'll do is we will simply pass the type of a constraint after that, means constraint keyword, then constraint name, and after that not null, that is the constraint type. So this is how you can simply create a not null column here. Alright, and let's add one more column here to check like what if I don't want to pass the constraint name. So for that I'll create another column like col2, again number, and after that you will not have to write the constraint keyword also if you are not giving the name, means constraint and constraint name will be in a group. If you want to pass the constraint name, only then you will use this constraint keyword, otherwise you are good to write this not null constraint directly. So let's terminate it with a semicolon, and you can see the table created. If you will see the structure of this sample1 table, you can see both columns are decorated with the not null constraint. After that, as soon as we will start adding the data in the table, you will see like any column who has been decorated with the not null constraint, you cannot pass a null value. Means you must pass some value by the time you are adding or updating a record in that particular column. But if you want to pass the not null constraint on an existing column or an existing table which you have already created, let's say I have already worked with the table called employees, alright, and here let's say in the first name column I want to pass this not null constraint. So for doing that, what I'll do is I'll simply say alter table command, alter table employees, and after that I'll say modify the column name, first name, the data type, that is bracket 2, and after that you can pass the constraint description like constraint, constraint name, employee underscore first name underscore NN, alright, and then the constraint type, that is not null. So let's say enter, and you can see table altered. So again I will go for the description of this particular table, and here you can see the constraint has been added in this particular field of first name, that is it's not null, and again the same data type. So this is how you can pass a not null constraint on a table by the time you are creating it or after the table is being created. We will cover the unique constraint. Unique constraint basically is used to ensure like any particular column would be having a unique value, means it is a non-duplicate value. You can easily pass the unique constraint in a field like mobile number or email ID in which you don't want any duplications. So this unique constraint, if you want to add these unique constraint, again you may or may not pass the name of a constraint. It's again optional for this or all the constraints, but this constraint can be added on the column level or table level. So if you will add this constraint on the column level, it will only be added specifically in that column only, means it will ensure the uniqueness of that column only. But if you want to pass this constraint on the table level, you can either apply it on the single column or multiple column. If you pass it on a single column, it will behave like same if you pass it as a column level, but if you want to pass multiple columns with the unique constraint, it will not check the uniqueness of a single value, but it will check the uniqueness of the whole combination of all the columns on which you have applied it. For example, if I have a couple of tables, like this is a table A in which there are two columns like C1 and C2, and in both the columns I have applied the unique constraint separately. So if I will enter 1, 1, it is unique. If I enter 2, 3, it's again unique. But if I'll enter 4 and 1, so this will give you an error. Why? Because this particular column is decorated with the unique constraint, so it will not allow you to pass the duplicate value. As 1 is already here, you cannot enter the 1 again. But if in another case I have the same table with the column called C1 and C2, and here if you apply a common unique constraint, then the combination uniqueness will be noticed. For example, 1, 1 is fine, 1, 2 is again fine, 1, 3 is again fine. Since you can see there are the repeated values, but I have not specifically added the constraint on this C1 column, it is a combination this time. So 1, 1, 1, 2, 1, 3 are the unique combinations. If you will enter it like 1, 2 again, then it will not be done because this combination is already present. So whenever you want to add the unique constraint or at the table level, and if you want to pass multiple columns into that, it will be happening in that case. So let's see how we can start working with the unique constraint practically. To add a unique constraint in a table by the time you are creating a new table, so it's a syntax is straightforward, like the create table syntax will remain same, like create table sample2, and after that you can simply put the parenthesis to start the column description. So let's say I have a column like col1, and here I'll put the data type, let's say number, and the constraint description. So for that I will use the constraint keyword, the constraint name, that is sample2 underscore col1 underscore, then any name like unique, since it's unique constraint. After that, the type of constraint like unique. Alright, so this particular column will be taking only a unique value, means if you will pass any duplicate data, it will not accept that. So again, I am adding this unique constraint at column level, because by the time I am defining this column, this constraint has been added. But if I want to add the constraint at the runtime, means at the table level, then let's see the syntax of that. For that, I'll say another column first, like let's say number again. I'm not bothered about the data type right now, alright? So you can pass anything you want. And after that, you can separate with comma again the third column. Once you are done with all the columns, you can close it. But here it's not over. I want to add a constraint as well. So when you are done with all the columns definition while defining a table, at last you can start defining the constraint. So for that, constraint keyword, then constraint name, let's say sample underscore unique, sample2 underscore unique, that's the constraint name. And after that you can pass the constraint name. Since it is at table level, you will have to specify in the parentheses like in which column you want to pass this unique constraint. So for that, I'll pass a column called col2. Alright, and after that I can close it and can execute it. You can also pass a number of columns which we have already discussed earlier, like you can separate them with a comma, and you can apply a single constraint on multiple columns. Once you are doing that, means a single value uniqueness, single column uniqueness will not be considered, but the combination value uniqueness will be considered. So let's say enter, and here you can see the table created. And obviously this table will be decorated by the unique constraint. But if I want to pass this constraint in an already existing table, such as employees on which we were working so far, so suppose in the column like email and mobile number, I want to pass the unique constraint. Here I will not go for this option, because obviously I don't want to compare the combination of mobile number and email ID. I simply want to check the individual uniqueness of both the columns. So let's say how we can do that. So alter table employees, and after that names are not case sensitive, so it's okay. Add constraint name, let's say employee underscore email underscore unique, and after that the type of constraint, means it's pretty straightforward, constraint name, and then constraint type. Alright, and here you can pass the column name. Make sure the column name should be exactly same. Case sensitivity is not an issue, but the name should be exactly same. So let's terminate with the semicolon, and you can see table altered. And very similarly I can do that for the mobile number as well. So mobile uniqueness, and here I need to change the column name again, that is mobile number, and you can see both the columns has been marked as the unique constraint. So this is how you can pass the unique constraint on a table which is already created, or if you are going to create a new table. We will cover the primary key constraint. There should only be a single column which can be assigned as a primary key, and when you make a primary key, that column will ensure that it must have a value, and the values must be unique as well. So let's try to add this primary key constraint at the column and at table level. So let's see how can we create a primary key for a table. So for that, if I want to create a new table, so create table sample3 and after that we'll start defining the each column. Let's say col1, and here just pass the data type, and after that you can add the primary key constraint like any other constraint. So at the column level you can simply say like constraint name like sample3 underscore pk, and after that the type of constraint, that is the primary key. Since it is at column level, you don't need to specify the column name after that, so you can simply say like that. But if you want, you can apply this particular constraint on the table level as well. So for that, what you can do, you can simply first of all done with all the columns which you want to define, alright, like col2 number, and after that you can simply add the constraint like constraint name sample3 underscore pk, and here you must pass the column name since I want to add column 1 as the primary key. Alright, you can also pass multiple columns here as we have already done with the unique, but if you will be passing multiple column, it will not behave like the primary key, it will be behaving like a composite key. So preferably we should create only one primary key for a table. So I'll not pass any other column here, and I'll simply terminate it with a semicolon, and alright, there is something missing. Alright, I didn't pass the constraint type. Alright, so let's type ed. As soon as you will do that, the last executed command will be open in the notepad in an editor, and here you can make the changes. If you want, you can start writing the complete command again. So here I'll just add primary key, I will say save, Control S, and then I will close this notepad, and you can see the command is written here, the modified command is written here. Simply say slash and enter, you say table created. Alright, so when you will see the description, means the structure of this particular table, that is sample3. So here you can see only not null. Later we will see like how can we check the description of all the constraints that we have in a particular table. So we'll do that later, but now let's see if I want to create the primary key on an already existing table, such as the employees table. Alright, and here I want to make this employee ID field as the primary key, because employee ID is something which is defining any employee uniquely. Alright, so what I'll do, I'll say alter table employees, and after that add constraint, then constraint name, that is employees underscore pk, and then type of constraint like primary key, and here you can pass the name of the column. So here the name of the column is empid, and let's terminate with the semicolon. Again you can place a comma if you want to create a composite key. Alright, now table altered, if you will see the description of this table, again you will just find the not null written after that. As I said, we'll check later how to see all the constraint which you have defined for a particular table. So this is all about the primary key implementation. We will cover the check constraint. Basically, in any particular column, where I want any value which is satisfying some specific condition should be entered, then I should go for the check constraint. For example, we have a column called gender in our table, where I want only M or F, these two characters should be allowed. None of any character should be allowed in that particular column. Similarly, in the salary column, I don't want anything less than 5,000 should be allowed. So such values can be validated by using the check constraint. So let's start implementing the check constraint now. So let's see how can we start applying the check constraint by the time I am creating a table. So here I will again write a very simple create table syntax like create table sample4 may be the column table name, and after that inside the parentheses I'll start putting the list of the columns. So maybe col1 is the name of my column, inside which I'm going to put some numeric values, maybe maximum up to 10 digits. So right after this I want to check like whatever value user is entering into this particular column, that value should not be less than 10,000 amount, means any particular value. So for that what I'll do, again check for check constraint and constraint name, which is always optional and recommended. Sample4 call1 underscore check. Alright, after that the constraint type check, and inside this parenthesis you will have to specify the condition. Let's say I don't want value less than 10,000, so any value in the call1 should be greater than or equal to 10,000. Alright, so as you can see, I am applying this constraint, check constraint, in the column level, but still I have to specify this column name inside the constraint type. Earlier, whenever we applied any constraint in the column level, we did not need to pass the column name. But since here I am putting a condition, and for putting a successful condition, you will have to specify both the things, means the value and the column name. So in the check constraint, there will not be much difference of putting the constraint on the table level or on the column level. So let's finish it up, and let's see, the table is created. So similarly, you can specify this particular constraint by the time of creation. Now, since we have already one table called employees, and let's say I want to apply a check constraint in this. So how can I do that? For example, I have a column called gender, which is accepting a single character, and I want that character should either be M or F. So for that, I will write alt table employees add constraint name, let's say emp underscore gender underscore check, and then the constraint type, that is the check. And inside this, what I'll do, the column name, that is gender. In is an operator which will accept a number of values inside it. So I want M or F should be there, not anything else. Alright, so what it will do, in operator will make sure like either this or this, means whenever you want to compare multiple values in equality, you can use this in operator. So when I'll say enter, you see table altered, and now by the time we will start entering the data in this particular table called employees, you will notice like we cannot enter any value apart from this M or F in the gender column. Alright, so this is about the check constraint. Now let's get started with the final constraint called foreign key constraint. Basically, foreign key constraint is added for the referential integrity. That means one column should refer to some another column, probably in the same or in different table. The referring column should have only one of those values which are actually there in the main column. For example, here if I have a couple of tables, that is the department table, in which there are a couple of fields like department ID and department name. Alright, so now I'll enter the department IDs into this particular column, and this will be decorated as the primary key. But in the another table, let's say in employees, each employee would be working in a particular department. And here also I want to get some department IDs. For example, here if I have the departments like 10, 20, 30, I want like, okay, if I have only these three departments, each and every employee would be working in any one of these departments. So for each record I will enter 10 or 20 or 30, or maybe in null also. But any employee cannot have a department 40 because we don't have department 40. So to ensure this particular thing, I should make this particular column as the foreign key, which would be referring to this column, and it will make sure like this foreign key column or the child column in the normal languages would be having only those values which are there in this primary key field. Apart from that, it can only take a null as well. So let's see what all and how we can achieve these goals using the foreign key now practically. So just as we discussed in the example, we have a couple of tables here. The first table is the departments table, in which there's a field called department ID, which I already created as a primary key. And here in the employees table, you can see there is a field called department ID. Now, as we just discussed, I want to make this department ID as a foreign key of this department ID, which is the primary key, so that here I can enter only those values which are available there in the departments table, department ID. So to do that, what I'll say is, I'll say alter table employees, because obviously I'm going to make the foreign key in the employees table. So I will say alter table for employees. Now, as always, for adding a constraint, add constraint, constraint name, emp dpt relation, or maybe foreign key, whatever you want. Alright, and then the type, that is the foreign key. So in which particular field you want to pass the foreign key? Like this, here I'm talking about the employees table, and here the field name is DPT ID. So DPT ID. Here by chance the names in both the tables are same, but it's never like that. It's nothing like that the foreign key and primary key must be having a same name. No, it's nothing like that. Again, you can put anything, any name out here. So this is about the foreign key. Here I just specified, like in the employees table, I want department ID to be a foreign key, but which column it would be referring. So for telling that, here I will say references, then departments means the base table inside which the primary key exists, and inside the parenthesis we will enter the column name, means the primary key column name. Alright, now if you will enter this command, if you will execute this command, the relationship will be there. But if you want later, means suppose here I created a department ID 10, and inside this I have a number of departments, number of employees working in department 10. So what will happen if I'll try to remove the record of department 10 from departments table? There are a lot of dependent records are here in the employees table. So I have a number of options out there, like on, delete, cascade. I can write these three words as well. What they will do, as soon as you will remove the department 10, all the related records in the department's employees table will be removed. Means if you will delete the department 10, all the employees who are working in department 10 will also be removed from the employees table. If you will write on delete cascade, similarly you can say on delete set null, means as soon as you will remove any department, let's say department 10, so all the employees who are working in department 10, their department ID will be set to null. Alright, but if you will not specify anything like that, so what it will do, it will simply will not allow you to delete the department 10. Means if there is any dependency of that particular record, the Oracle server will not allow you to do that. So here I will say on delete set null, because deletion is never a good option. So let's execute this, and you see table altered. Now after this department ID can have only those records who are already there in the departments table. And if you will delete any of the department ID from departments table, the relevant records in employees would be having a null in their department ID. So now, since we have covered all the 5 constraints like not null, unique, primary key, check and foreign key, in this video we'll see how can we manage a constraint. Means if a table is already created, then how can we add the constraint at the runtime, how we can view the constraint which is already added in a particular table, how to disable that, how to enable, and how to drop a constraint. So let's see practically all these operations now. So for viewing the constraint which we have already created on a particular table for the particular columns, we have the data dictionary here called user constraints. Here in user constraints data dictionary, you can find some columns like constraint name, constraint type, table name so that you can actually see what all constraints are available on a particular table. So here I'll do a very simple query like select. We will have a deeper discussion of select statement in our coming videos, but here I'm just showing you like how you can get the details. So for that, here I will write a command like constraint underscore name comma constraint underscore type from user underscore constraint, which is the view name. Alright, where means I don't want to see all the details, I just want to see for my particular table named employees. So where table underscore name is equal to employees. Alright, make sure you are entering the table name in full caps so that you can check actually. So here you can see like the unique constraint for U, primary key for C, relationship means the foreign key for R, and the not null is also here as specified as the check constraint because it makes a check like the current details should not be a null. So it will also be represented as a check constraint. So check constraint for the first name and the gender, which we have set it while implementing the constraints in the employees table. Now, if you want to check like on which particular column these constraints has been marked, first of all, if you will put the name logically, it will be easy for you to understand the things. Like here you can just see the name of a constraint and you can check like, okay, it's for first name, it's for email ID, it's for mobile number. But if you haven't specified the name in that sense, you can also have a look on that such particular means column names in which you have applied this constraint, and for that what you will have to do, you will simply have to go for the user cons columns. Alright, that is the data dictionary. So here you can see this is a column name, so it will be easier for you to get that. So let's have a select statement for this. So I will select constraint name and column name from user underscore cons underscore columns, where table name is equal to employees. Alright, so here you can see in DPTID it's a employee DPT relation. On the field gender, it's gender check. On EMPID, it's the primary key. Similarly, on mobile number, it's mobile UN, that is unique constraint. So in this way, you can have a look on such type of constraints. Now, after having a look on those things, if you want to enable or disable a particular constraint, you can do that as well. Like for example, for a time being, I want to remove this check constraint from my employees table. So for that, what I'll have to do is I'll say alter table employees. Now disable constraint and then constraint name. So here you can see like it's emp underscore gender underscore check. Alright, so you see that is disabled, and now since in this particular constraint I made sure like only M or F, these two values will be allowed in the gender column, but now since it is disabled, you can enter any particular character in that particular field. But make sure before enabling you will have to make the data concurrent to this particular constraint. Means if while enabling this constraint, if you have entered anything which is not acceptable by this constraint, it will not be enabled. So here what I'll say, I'll just say enable in order to enable this constraint. I don't have to specify anything else. But if you want to drop the constraint, you can simply remove this enable or disable, or here you can say drop constraint name. Now you cannot enable it, you will have to recreate the check constraint as you did earlier while applying this check constraint in this employees table. So this is how you can manage a constraint after you've already added the particular constraint on a table. So far in the Oracle SQLs, we have covered the data definition language along with the constraints. Means now we can create a table with validating the table using the constraints. So let's see what about the data manipulation language. Any SQL commands using which you can add, remove or modify the data inside a table, you can categorize that inside the data manipulation language, or in short DML. So basically, whenever you want to add a new row or a tuple or a record, you can go for the DML insert statement. Similarly, using the update, you can update or change the existing record in a table. And you can also delete the data by using the delete keyword from a table. If in a single block you perform the number of DML activities altogether, you may call it the transaction. And for the transaction, you can go for the commit if you want to save the changes, and if you want to roll back the transaction, you can go for the rollback command. So these are all the things very basic related to data manipulation language. Now let's see what all commands are there inside DML. So here you can see insert, which will insert a new record. Update keyword will update the existing records using depending on the operator which you are using. Similarly, delete, if you will not pass any condition, all the records will be deleted. If you pass the condition, then any record which are satisfying those conditions will be deleted. Now merge. Merge will be combination of insert and update, means it will be a conditional insert and update in which we will go for the two tables at least. Now let's begin with the insert statement, which is a part of the data manipulation language, that is DML. So using this insert statement, you can actually add a new record in a table. Make sure while inserting a new data, you will have to follow the same sequence of the columns which are present there in the table. Means while creating the table, we listed the number of columns in a particular sequence, and when the table got created, it was having the same sequence of columns. So while inserting, we will have to make sure that I am passing the value in the very same sequence, and also I am making sure that I am passing the data in a right data type. Apart from that, we'll also can do one thing, like if you want, you can, along with the table name, you can pass the column names in a particular order, any random order, and in that particular case, you can pass the value in that way. Here in the implementation, we will also see how to insert the default and the null value while using the insert statement. So let's see practically how to do or how to deal with the insert statement. For adding a new record in this employees table, first of all, we will have to know the structure of this employees table. So here, as you can see, there are 8 fields out there in this particular table of respective data types, and by the time we created a table, after that we have added some constraints in this particular table. While adding a new record or while updating the record, you will have to make sure that any value that you are entering is not violating the rules of the constraints. So let's see how can we start adding a new record. So for that, first of all, I will use the insert keyword into the table name. Alright, you don't have to write table keyword, but insert into employees. So it will make sure that I'm going to insert the record in the employees table. So in the first syntax, I will not name all of these columns. So what I'll have to do is I'll simply write values keyword, and after that I can open and close these parentheses inside which I can pass different values. So we have to make sure if we are not specifying the column names in the insert statement, we will have to focus on and we will have to pass the same same sequence of columns. For example, if at the first position I enter 101, that means 101 is for employee ID. After putting a comma, I'll have to enter something in the first name. Let's say I entered Anadi. That will go to the first name. And since you can see it is not null, you will have to pass some value. Similarly, after that last name, I will enter like Sharma. Again, in email ID, let's say anadi@tutorialspoint.com. Then gender. In gender, I specified a check constraint. So the check constraint is either M or F. So here I'll go for M. You can actually check, like you can try some value which is violating the constraint to see what error you get. Similarly, mobile number, let's enter something randomly. Then date of joining. In date of joining, basically I already entered a default value while creating this, but if you want, you can call some special values as well, like sysdate. So it will take the system date, that is the today's date which is there in the system, and that value will be inserted. And later, finally, you can add a department's ID. Department's ID is something which is related to the department's table. Currently, if you want, you can make it null as well. Later, we can make the updations. So let's put a semicolon here and say enter, and you can see one row created. Similarly, if you want to put a record in the departments table, you can see the structure. It's departments. All right, it is the small table, only 2 columns are there, so you can go for the very same syntax of insert. Like here, just a couple of values are required. For example, 10 comma admin. All right, so all right, sorry, I forgot to change the name of the table. Insert into departments, and here you see one row created. Similarly, you can enter multiple values out there like this. And if you don't want to put the value again and again, you don't have to write this particular syntax again and again. What you can do, you can use it as a script by putting some placeholders. For placeholder, you can simply put an ampersand symbol, say ID, and here inside single quotes say ampersand name. All right, and just enter. So enter value for ID, it's like a parameter now. All right, so what you will have to do, you will just enter value 30, and for the name, training, enter, one row created. All right, again you just need to put a slash, say enter. You see, you don't have to write the complete syntax again. So enter a value for ID. Again, you can put any value, say 40, and let's say the department name is development, dev department. All right, or DevOps. So this is how you can keep on inserting the values. Finally, you can say commit in order to save all the changes. All right, we'll discuss about these commit things and the transactions in our coming videos, but for now you can see how can we insert the values. Similarly, now if I again talk about the employees table, the bigger table, if in the second syntax, what I can do is insert into employees, and right after employees I can actually pass the name of the columns. For example, EMP ID as the first column, then last name, then first name, gender. All right, you can take any random columns out here. All right, let's say DPT ID. All right, so for all the columns which I have not included in this particular query, they will be having a default value. If you have specified any default value for a particular column, that default value will be entered, or otherwise the null value will be inserted. So let's say values now. Now let's talk about the employee ID. Let's say employee ID 102, last name, let's say Kumar, first name Mohit, gender M, department, let's say 20. Alright, so enter, you see one row created. If you want to see all the records which you have inserted in the table, you can do that by using the select statements. We'll talk about the select statement deeply in our coming videos, when we'll definitely talk only about the select statements. But for now, you can see there are 4 records out there in the departments table, that is DPT ID, DPT name, and there are 4 records 10, 20, 30, 40 with the respective departments. Similarly, if I would like to retrieve the data of employees table, you can have that as well. Alright, as you can see, there are a couple of records 101, 102. Alright, so these are the couple of records which I have inserted. So this is how you can add the new records in the table. As here you can see, the output is not much clear as it is being split into multiple lines. You can actually set that by setting the width of a particular column, and for doing that you can simply write the SQL plus commands like column, column name, format, and the alphanumeric for A, and 10 means the width of the characters, means in this particular column only 10 characters can be shown. So similarly, I have set the column last name and column email ID in my output, and you can see the output is much clear. You can still shrink the width of the column if you want more, and if you want you can just remove some of the columns if you don't want to get the complete set of columns for a record. So this is how you can make your output more clear in the SQL Plus environment of Oracle. We'll cover the update statement of DML. So while updating a particular record, you have to specify the particular condition, and any record which is satisfying that condition will only be updated. If you will fail to pass any condition, the changes will be made in all the columns. So it's all upon you, like whether you want to update a single column or multiple columns. So now let's see practically how we can implement the update statement in Oracle SQL. So in order to update the existing record, here I am having a couple of records right here which I have already inserted while discussing the insert statement. So there are 2 employees, 101 ID and 102. Now if I want to make the changes in any of the fields, so let's see how we can do that. So first of all, I'll use the update keyword because we are going to update an existing record. So update, then table name, that is employees in this case. After that you will use a set keyword where you can specify all the fields in which you want to make the changes. Like for example, I want to make some change in the department ID and I want to set the value to 30. If I will execute this statement here, all the records, means currently only 2 are here, but when you will insert the bulk of records, all the records will be changed and the department ID for all the records will be 30. So if you don't want to make the changes in all the data, you will have to specify a condition, and here we can pass a condition by using the where clause. So here in the where clause, what I'll do is I will pass any condition which will point out a specific record. So here let's say I say 101 means EMP ID is equal to 101. So since it's a primary key, multiple employees can't have the same employee ID. So only this employee is having ID 101, and when I'll say enter, it will show you one record updated, and when I'll write the select statement for this, you can see the department ID for 101 is now 30. Similarly, if I will try to update the value for multiple columns, I can do that as well. So like here, after the set keyword, I'll pass a multiple columns, like for example, mobile number is equal to let's say any random value. Alright, now after that you can simply pass a comma and can pass some more columns like last name is equal to any different value. Alright, currently maybe the value is there or not, maybe the null is there, but you can anytime change the value which you want. Similarly, date of joining is equal to Alright, so after specifying all the values, you can simply specify a condition like emp id is equal to 102. So all the changes will be there for the second column only. Like now here you can see last name is being modified from Kumar to Dubey. There was no date of joining and mobile number earlier, but here now you can see both are having a specific value. Alright, so this is how you can specify the update statement in order to make changes in the existing records. We will cover how to delete the data from a table. As in the previous video of update, we learned how to pass the condition using the where clause. Similarly, I will have to use the where clause in delete statement as well. Otherwise, all the records in the table will get deleted. So let's see practically how to work with the delete statement. For deleting the data, first of all you will have to write a delete keyword and after that an optional from keyword. Even if you will not write from, it will define and the syntax will be working correctly. So delete from, after that you will have to specify the table name. If you will execute this particular command, all the records will be deleted, though you can roll it back, but you will not be able to filter the particular record which you want to delete. So for specifying that, you can go for the where clause, and here you can specify any particular condition like emp id is equal to 102. So as soon as you will do that, that particular record from 102 will be deleted, and after that if you will select the record again, you will not find that particular data. Though whatever changes we are making using the DML are not saved permanently, means first of all either we have to commit or roll back in order to save or discard the changes. But we are not focusing on those things right now. We will obviously do that once we are done with each statement of DML. So as we have just seen about deleting the record, so this is how you can delete any record when you want to. We will start with the merge statement. Basically, merge statement is used to do the conditional insert or update in a particular table. In this particular example, I am going to use two tables having the similar structure. So let's find out practically the implementation of merge statement. So for implementing the merge statement, here I'll go for a couple of tables. Basically, I will create a backup or a copy of this employees table. So for doing that, I have created another table here named copy emp. Basically, the structure is similar, but I have not taken all the fields because for the demo purpose, we are good enough to continue with these number of fields as well. Now, what I will do is, first of all, I will make a comparison between the employee ID of copy emp table and employee ID of employees table. If the employee ID of copy emp table is matched with this table, then I will update all the fields, that is first name, last name, mobile number and department ID from this one. Maybe there is a scenario like the employee got updated, maybe the last name or the mobile number or the department ID got changed. So in order to just make a sync, I will do a conditional updation in the copy emp table. But if the employee ID in copy emp is not matched with that of the employees table, then I will insert that record using employees table. So let's see how we can do that. So first of all, let's clear the screen. I'll start writing it from the top. Alright, so first of all, we'll start with the merged keyword. Alright, so merge into, then in which particular table you want to merge, means make which table you want to make a copy. So that is copy underscore emp. Alright, if required, you can make the alias of this particular table. And using which table you are making this merge statement. First table is the copy emp in which you want to copy the data, but from which table, that you will specify here, that is using employees. Alright, using employees E. Now E is again the alias, and you will have to specify like using which field you are going to merge. As I said, like primary key should be there. So on E dot employee ID, emp ID is equal to C dot EMPID means the field names are same, that's why I'm putting it like that. Alright, so here I specified like which is my main table, from which table I'm going to take the data, and which is the common field. Now after that, if the primary key fields got matched, so when matched, then alright, then what all you want to do, you want to update. So simply write update set, and what all fields are available, like c dot first name is equal to e dot first name, because ultimately I am putting the data in the copy table, that is C, the alias is C for that. Alright, so first name, make sure you are putting the same name every time, separate with comma, then C dot last name is equal to E dot last name. Similarly for the remaining fields, so apart from that I have taken mobile number is equal to E dot mobile number, and last is department ID. Alright, so C dot DEPT ID is equal to E dot DEPT ID. Alright, so you'll have to write till this point. Now when matched, then I wanted to update. When not matched, means the employee ID doesn't exist in the copy table, then I have to insert a new record. Alright, so when not matched, then you will have to pass the insert statement for that. Alright, so insert into table name, that's the proper syntax, but here you don't have to say into table name because it's already being mentioned using the merge statement, so you can directly start with the values. Alright, and here I'll start writing the values from the employee ID. So E dot EMPID is the first column, second column is the first name, then last name. I'm talking about the structure of copy EMP table, then mobile number, and finally the department ID. Alright, so I think it's good enough. Let's see how the output is looking like. 4 rows merged, because if I'll see my employees table, there are 4 records here, 1, 2, 3, 4. Alright, means 101, 102, all these 4 records are there. Similarly, if I'll see my copy EMP table, now there are also these 4 records. Alright, now let's do one thing. Let's make a change in the table. For example, I will update the department ID of 101. Since we have already done with this particular command, let's see. Update employees set DPT ID is equal to 30, where EMP ID is equal to 10. Sorry, EMP ID is equal to 101. Alright, so this one is updated. Now let's run the merge statement again. Alright, you can make it as a procedure also, but we'll discuss about all those things later. So I am simply writing, or I'm reusing the command thing again. So you see 4 rows got merged again, but now when I will query from this copy EMP table, you will find all the changes have been reversed. Means a new record is not here, but since 101 would be matched with the employees 101 record, so it got updated. So this is how your merge statement works. When the matching record will be found, it will be updating it. If the matching records are not there, then a new record, means that missing record, will be inserted. We will cover the transactions. Basically, whenever we write a basic SQL statement of DML, the transaction begins. Means as soon as you will write the insert, update, delete or merge statement, at that particular part the transaction will begin. You can keep on writing multiple DML statements in order to make a single transaction more logical, but at the end we need to finish that transaction so that our data would be in a consistent form. So whenever you write a DML, that will be a transaction, but as I said earlier, while working with the DDL, and also you will see that in DCL, that these commands, means that any command under DDL and DCL are auto committed, means you will not have to manage them, but as far as the DML statements are concerned, you will have to manage them with the commit or rollback things. So if you are working with the DML statements, at the end there will be two options: either you are satisfied with those changes and want to commit that, or you want to roll them back. Whenever any user from a schema does a DML statement, at the end he can see the affected data. Means if I am writing the insert, that is what we have done so far, alright. If I have written the insert statement or delete statement or update statement, at the same time I am able to see the changes, but any user which is accessing my data from the external schema will not be getting the actual changes. So for that we actually have to save the data in a particular consistent form. Either we'll have to save all the changes or we'll have to roll back all the changes. If everything is going smooth, a writer, means anyone who is writing the commands, can use the commit or rollback command. Commit will save the changes while rollback will undo all the changes made. You can also end a transaction by issuing a DDL or DCL commands. As I just said, these are the auto committed statements. So whenever you will write or execute the DDL or DCL command, it will commit all the uncommitted DMLs as well. Or the command editor exits, means when you close that command prompt on which you are working. Now it depends whether you are terminating the command prompt normally or accidentally. Means if you are properly exiting from the terminal, then it will be considered as the commit, means everything is fine. A user deliberately terminated the command, so it is considered as the normal termination, so the commit thing will be there. But in case your command prompt is exited abnormally, means you directly click on the close button on the cross and you exit from the command prompt, that will be considered as the system crash. So this is all the pending or uncommitted DML statements will be rolled back. Similarly, when the system is crashed, obviously it is not a consistent way to terminate the statements, so it will undo, means it will roll back all the uncommitted DMLs. Save point can be placed in the transaction as a marker for rollback. Suppose there are n number of statements, like I want to create 10 DML statements for a transaction. But at a certain level of time, I noticed like I want to roll these transactions up to last 3 statements. Means, for example, if I have executed 3 statements earlier, 3 statements afterwards, I want to roll back these 3 statements which I executed later. But if I will do a rollback, all the uncommitted and pending transactions will be rolled back. So in order to add the marker, you can use the save point keyword, so that at a particular level you can choose like up to what level you want to roll it back. So let's see practically how to start working with these transactions using the commit and rollback. So for understanding transactions, here I will use 2 different terminals. This one is for system, means as you can see, the user who is logged to this particular system is name is system, and here the user sys is getting connected. Now here system user actually owns a table called department on which we have already worked. So let's have a look quickly. So here you can see like departments is a table having 4 records, and this system user also allowed this sys user to access this particular table. So how this user will access that? Simply like select asterisk from system dot departments. Alright, so first of all we'll have to use the schema name, since the departments table is not in his schema of sys. So first of all, schema name, that is system, that's username, and then the table name. So as you can see, both the terminals can access the same table. But now if this user, that is system user, will make any changes to that, for example I'll insert a new record, let's say insert into departments values, and here I'll enter a couple of values like 50 and IT. Alright, so you can see one row created. If I'll do a select statement here, so you can see the fifth record is getting shown now. But if I will do the same thing here again, you can see there is no record 50. Why? Because the changes have been made, but so far there is nothing like saving or discarding the changes. Whenever one user will do some changes, he can see that uncommitted changes as well, just to have an overview like, okay, how that particular record is looking like. But since it is not permanently saved into the memory, the other users cannot see that. If I'll come here and will say commit, in that case the transaction is completed, and now another user can also see the department 50. Alright, so very similarly, whatever the changes any user will make, it has to make a commit or a rollback in order to save or discard the changes. For example, if I will delete, I'll say delete from departments without passing any condition, you can see 5 rows deleted. So obviously if I'll make a selection, I'll get no rows selected. But if I'll come here, I can still see those 5 records, because yes, it's being deleted but not from the main memory. So if I'll say rollback, so even he can see all the data and sys can obviously see the data. Alright, if you will not write this commit and rollback in order to make the complete save or discard, you can also choose like for example, if I'll say let's insert a new record, insert into departments values. Here let's add a new technical writer. Alright, so you see one row got added. So obviously I'll not be able to see it here, but if this particular user will terminate his session properly means I will say disk, means I'm getting disconnected. Alright, so when you disconnected, normally that record will get committed and then your session will be ended. So as you can see here, as I said disconnect, I can see the data right here, because that will make it committed. Similarly, let's connect again, connect system, here's the password. Alright, so now I'm connected. Let's clear the screen first. Alright, and now what I'll do, I'll say delete from departments. Alright, so this command deleted 6 records, but now I'm just closing this window abnormally. Alright, when I close this window, that means the system got crashed and I could not able to terminate my session properly. So in that particular case, the command is rolled back, and you can see this sys user can still make a request for those 6 records. But if I'll reconnect here using SQL plus system and the password, and now if I'll again make a selection for that particular data, that is select asterisk from departments, again I can see those 6 records, because though I deleted, I didn't say commit or rollback, but my session was terminated abnormally, and just because of that you can see like the transaction got rolled back. Similarly, you can also fire any DML any DDL or DCL command in order to make the commit, because whenever you will execute any DDL or DCL command, it will be auto committed and it will also commit all the pending DML transactions. Now, in order to split your complete transactions into smaller parts, I can also go for the save point. So let's clear the screen here and see how this works. So first of all, what I'll do is I'll update the record. Let's read the record first. Departments, all right. Okay, so here what I'll do is I'll say update set DPT name is equal to human resources, where DPT ID is equal to 20. Alright, there's some misspelling. Okay, no issues. Let's correct it. Update department. So one row updated. Similarly, I'll update another one. Information technology, where department ID is 50. Alright, the size of column is maybe lesser. Okay, so information tech. Alright, so both the records have been updated. Alright, so but obviously I haven't made any commit or rollback things. I will create a save point here. Let's say save point, and just give any save point name like updations. Alright, so it will create one save point, means any transaction which is executed before this save point will be protected by this save point. If I will undo till this point, it will not roll back the previous transactions. Now let's do one thing, like let's create and let's do some more operations here, like insert into departments values, and again a couple of values like 70 and maybe any department like DPT1. Alright, so again I can go for the save point insertions. Alright, so now I have a couple of save points. If I'll do the selection right now from department, so what I'll see is I'll see the updated records and one inserted record, that is DPT1. Now let's do one thing. Let's say roll back to insertions. Alright, so it will say rollback complete, and if I'll select it again, you can see this 70 and DPT1 is still there. Why? Because after insertion save point, I have not done any DML operation. This is the place where I have created this save point, but after that I have not executed anything. But if I'll come here again and will say roll back to updations. Alright, and now when I'll see here, you can see the 70 record is not here anymore. Why? Because it was done after the save point updations, and whenever I will roll it back to any particular save point, any transaction after, any uncommitted transaction after that save point would be removed, it would be rolled back. But if I'll come here and will make a selection, you can see HR and IT are still coming in the short, while here I have done the updations. That means, like, obviously the transactions were rolled back, but the uncommitted transactions are still uncommitted. They have not been committed. So what I'll do is I'll say a commit, and now when I'll request here, you can see the updated data. So this is how you can use the save points in order to do the partial rollback in your transaction. But this save point thing will not be suitable for your commit, as the commit will commit all the due and all the pending transactions.